If you have a polygon and you want to split it into more polygons, you can do this sort of splitting, but what you want to be aware of is that you're actually creating new topology as you do this. So in this example here, we start with this one purple polygon here, and then we draw a line through it that's going to split that into two polygons. Of course, it's going to cross the existing polygon at two of its boundary points here, but then we're also going to define the edge of that split, or what that split looks like within this polygon by all of these vertices here. So as we click through, we'll click first outside the polygon, and then on the edge, then all of these points here, and then on the outside. And that's going to create two new polygons. If we want to split that again, we can do the same thing. Now instead of one polygon, we're splitting two different polygons. And because we do this in the same systematic manner, we're going to, in the end, have four different polygons, each of which has its own topology associated with it. So this, the splitting command does recognize the topology, or basically how many different polygons we have. It's not just a drawing tool, we're actually building new polygons this way. But we have to be careful with this map topology. For example, let's say we have a map that, that starts out looking like this blue outline here. And then we go in and we move some of the vertices. We move this point to here, we move this point to here, this point to there. What we're actually going to end up with in that case is we're going to modify this one polygon here, but we didn't modify this here because of the way the map topology is set up, because we're actually editing one of the features, which is this polygon in pink here. So we're modifying this feature, but we're not modifying this feature out here, which has not been selected. So here we're building a new map topology, but what we have to remember is if we build it this way, we're going to have a donut hole here where we don't have any sort of feature associated with this area here. So how can we get around that? Well, instead of editing the feature, we can edit the edges. And if we edit the edges, it's understood that as we make these changes along the edge here, that we not only want to change the pink polygon on the inside of all of these, but we want to change the brown polygon on the outside as well. So as we move this point to here, and so forth, the GIS understands that now we want to rebuild the topology of both the pink polygon and the brown polygon, and gives us a much different result as in the previous one, because we're modifying the edges instead of modifying the features. And this shows another example of topology with lines instead of polygons. Sometimes with lines we might want to do something like this, where our streets are originally in these locations here, and we want to grab this node, and we kind of want to pretend like we're just grabbing everything here, both of these cross streets, and we want to move all of it down to this new location here. So in this case here, we've stretched, it's called stretched geometry proportionally, and what we've done is we've made sure that everything else out there is coming along with this node that we're moving. But in other cases, if we don't stretch the geometry proportionally, if we move one of these nodes, it's just going to deflect that until it gets to the next vertices. So this would be the node here where everything crosses. The first vertice is out here, and out here, and out here, and out here. And those things have been deflected with a node, but not the rest of the line like we see if we do this command, which is stretch geometry proportionally. So both of these things could be possible. We might want to edit these, this topology in both of these different ways. So we just have to be aware of what we're doing and how we'd like to do that while we're doing these sorts of edits that affect the topology.